Hello guys, this is Shahbaz Masih, and today I will show you how to build a simple web app, a machine learning web app. And what it does is it predicts power output of a combined cycle power plant, and the input that we give to it is actually the type of the model that we have already trained on the back end, and then we enter the ambient conditions of temperature, pressure, exhaust vacuum, and relative humidity. And based on whatever our entered numbers are and the type of the models we choose, it predicts the power output of the plant. So just for demonstration purposes, you can pick a decision tree regressor model or say random forest regressor here. And for temperature, it's in degrees C, and you can give it a value of 35 degrees. And exhaust vacuum, that's in centimeter of mercury, and let's say it is 70. And pressure, the atmospheric pressure is in millimeter of mercury, so let's keep it 1000. And then the relative humidity, let's say it's around 45%. And now based on these conditions and the type of model that we have chosen, the model will predict the power output. So here you can see that we choose a random forest regressor model, and based on that it has predicted this power output of 430.85 megawatt. And similarly, you can choose a different kind of model, and it will enter all these values of ambient conditions, and it will predict the power output for that particular model. So now what went to build this model on the back end is first of all, I will show you the data that was used. And here you can see that I use the ambient conditions data, and here is the power output. It's online repository data, and I've used part of it to train the model and part of it to test it. And you just copy and paste this file, whatever your data is, and right click on the project that you have created in Pycharm and just paste it here. So now the tools that we have used to build this web app is HTML, CSS, and then this Pycharm or Python. And to create kind of an interface between web app and our models, we have used Flask, and I will show you how they all combine together one by one. So first thing we will start with is our web page. That's the HTML page, and here you can see that I just started with the form, and its action is taking us to the URL when we press the submit button to the predict output, and it's posting whatever input we are entering. So here there is a select attribute to form that model selection parameter. There were three kinds of models that you just saw. One was linear regression model, then decision tree regressor, and the third one was random forest regressor. So one point that I want to mention you here is, so we have set this parameter as required, so that you must have to select it before you hit the submit button. So if you keep the first value empty and give it a text of choose machine learning model, it still takes it as no value entered, because the value is empty string. So that is just a small trick. Otherwise you have to write a long JavaScript code to tackle this issue. It is just built in within HTML. And all the parameters for input, the environmental conditions, you can see that they are all numbers, so you cannot enter text in the website. And then I've set minimum 0, so you cannot enter the negative values. And here the step is any. If you don't mention that, then you can enter only integers, but here you can also enter decimal numbers or float parameters, and also all these parameters are required. So then when we submit that button to predict the power output, it renders this text that I will talk about in another file. That's prediction text. And then on the top, for this HTML file, there is a style sheet, and it's sitting in static folder. Under that there is a CSS folder, and then the file name is style.css. So just make sure that all our files are in the respective folders. So here is a static folder, then there is a CSS folder, and then there is a style sheet in the CSS folder, and there is HTML. It's actually under the power plant folder. Sorry, under the template folder, because we will be rendering templates, and I will show you that as well. Then style sheet, you can pick any style sheet, from bootstraps. You can format the individual parameters, but it's all up to you how you want to design it. I will not talk about that. Then for the app part, first I'll show you the model, how we set up the model. So after you copy and paste your data onto the folder, the project folder, then you can just read that data by importing pandas and .read underscore CSV file, and here is the file name. And then I just checked if there are any missing values, and there were no missing values found. And here I just used IQR score method to remove the outliers, and there were around 100 outliers removed by this method. And then the filter data was actually used for further analysis. I used a train test split method in the model selection class from scikit-learn, and split the data into test and train, and testing data is around 20% of the data. Then that test and train data was further divided into independent and dependent variables. So here I picked all the 4 variables as independent variables and put it in data called xtrain, and the ytrain is whatever output parameter is. That's the power output of the CCPP plant. So the next step is how we select the model and train it. So from scikit-learn, I just picked up the linear model and imported linear regression model, and here I am building that model and passing it only one parameter, that's fit intercept. So there must be intercept that should be fit. It's up to you guys to decide how many parameters you want to add in here and how many you want to tune. If you want to know what parameters and how to tune them, you can look at the previous video that I have published already. Then after we build the model, then we train it by passing the training data set. And after we train the model, then how do we save it in a place where we can use it in our web app? And that's where pickle library comes in handy. And here I've used the dump method of the pickle library. Here I'm passing that train model, the linear regressor model, and now I'm writing it on a model called lrmodel.pkl. This is a very important step. Here I'm serializing the object data of the model and saving it. in this model called lrmodel.pkl, and from here I can just pick it up and use it anywhere in my web app. And to do that, we use Flask in the middle that I will explain later. And here, to use it, you can just load this model by using this pickle class. And here is the model name that we just saved, and here we are just reading it. And now, by passing these values and using the predict method of the model, we can just predict the output from the model. Right here I'm just passing the 4 parameters values, and I will run it at the end of the file to show you guys the results. So same thing I did with the decision tree regressor. Again, I imported it from scikit-learn, and here you can see that I passed only one parameter, that's mean average error, and it's up to you guys again how you want to train it. And I have discussed this training and tuning in my previous video if you want to look at it. Again, I used that model and trained it by using the training data set. And then again, I'm using it by first saving it in DTL model, and then loading it again and reading it. And then by passing these values, I can predict the output from the model for the grand power output. And same thing I did with the random regressor model, and I imported it from scikit-learn. And here again, I used this parameter of mean squared error, and training it and then using it to predict the values. So now, if you run this model class, you will see that how Pickle actually serialized and deserialized the model to use it and predict the values. So here there are 3 different models and 3 different values were given as output, and I have passed the same values for all the models just to see the comparison, how they differ in terms of output. Now, how we are using this model in our app. So you go to app class, and how you build it, you just right click on the project folder and say new, and you can pick here the Python file and create it. So now how we created the interface between our model and the web page. That's where Flask plays an important role. So from Flask, I imported Flask, the object itself, then request because it's a web app. It's actually a micro web app. And then render template because we will be dealing with HTML pages. So here I'm just instantiating it by writing a constructor, and I named it as app. And here the saved model that we have saved previously in lrmodel.pkl, I'm just retrieving them by using load method and reading them and saving them in respective models. LR model, that's a linear regression model, then decision tree regressor model, and random forest regressor. And then by using app.route, that's how I've defined the home page, and you just go to index.html page, the HTML file that I just showed you guys. And so when we run the app, it goes to this index.html file, and when we post it, it actually takes us to this second URL, that's a predict output, and we are posting our whatever input that we have given it. And how we are predicting the power output, that's the method that's defined here. So here you can see that I'm using request on the form, and for the value that I have input for the ambient temperature, and I'm just reading it and saving it in a parameter called AT, that's ambient temperature. And similarly for other parameters, the vacuum pressure, I'm reading it from the form by making a request and saving it in a parameter called v. And from all these parameters, I have read them. I have saved them as a list in a list called parameters. And by just using the for loop, I'm converting all the parameters in the list to float and saving them as float features. And then I'm creating a numpy array from this from these parameters that it's already converted into float parameters. And how we are reading the model type. Remember, I showed you we can pick one of the models types. And here, if you choose linear model, then we are predicting the output by using linear model that we have saved at the top by reading that pickle model file. And I'm passing those float parameters list. And here, how we are generating the output. So I'm saying whatever the output is, the parameter is, just round it off to 2 decimal points. Then how you are rendering that output text. If you remember, I showed you in the HTML file. Here it's prediction text at the end of the page. So here, that's the index.html render template. And here I'm using this output that we have just rendered here, and I'm passing this text as the prediction text here. Same thing if you pick the another kind of model like random forest regressor, and it will pick the random forest regressor model to predict the values for the parameters that we have passed in, and that prediction value, that's the output, will be rendered in the prediction text. So I think that's all that I have to show now how to run this model. So here I'm saying if the name is equal to main, then run this app. So you can run it either on the terminal or on the on this app here in Pycharm. So you can just select the app class and run it here. It will output a URL, and you just click the URL and it will take you to this model page. I have put all the code in the bottom for the GitHub repository. The link is there. And here, just to demonstrate further the features that we have put in the HTML file, in case you don't select any model and you say predict power output, then it gives you the message because it's a required field, so you must choose an item from the list. And if you pick a model, let's say decision tree regressor, and here if you enter negative values, let's say -10, and say predict power output, then it gives you a message that number must be greater than 0. These are just the small checks I put in there so that the model doesn't crash, and it just takes care of those small errors. And same thing if you enter a text, and first you have to put in the required parameter value. That's the temperature. Sorry, it's 115 degrees. And if you hit enter, then it says it must be a number. And here you can add a number. It's the vacuum pressure in centimeter of mercury. So you can enter here 30. Then the next value is the atmospheric pressure. That's in millimeter of mercury. So let's say it's 1000. And then relative humidity, let's say it is 30%. And now, because we have chosen decision tree regressor, and previously we had chosen random forest regressor, now based on whatever selection we have made, and as I showed you guys in the program, it will predict the power output. So this is the decision tree regressor model, and that's how it has predicted the power output based on the corresponding model that's already trained on the backend. Thank you very much, guys, for watching this video. That's all what I have to show you.